Hello, welcome back to Molecular Biology Review, and I'm your host, Ryder. Well, today I'd like to talk to you about vaccines, and in particular adjuvants of vaccines. So we're going to take a trip, a little bit of chemistry, but also quite a bit of immunology in this week's episode. As you may know, there are two types of adjuvants: heat-killed or attenuated live vaccines, but there are also increasingly popular synthetic protein-based or subunit of protein-based vaccines. And these vaccines, despite being technologically advanced, they are less potent and therefore require adjuvants. So there's always a search for new adjuvants that are stronger than the traditional ones, such as alum. One such adjuvant has been isolated from a rare tree in Brazil called Quillaia, and the compound, the small molecule, or rather, it's a pretty large small molecule, is called QS-21. So this paper that just, not so recently came out in Angewandte Chemie is called Synthesis of QS-21 Xylose, Establishment of the Immunopotentiating Activity of Synthetic QS-21 Adjuvant with a Melanoma Vaccine, and it's from the laboratory of David Ginn, or Gin, I'm not sure exactly. Right, so let me just give you an overview of how exactly complicated this molecule is. So maybe you can see it there. So basically we've got this large 5-ring kind of steroid-like structure called the quillic acid. It's then glycosylated with a trisaccharide domain, and further on this end is further connected to a tetrasaccharide that can have one of two endings, as well as this sort of amino acid-like or polyketide-like, what do they call it, acyl group. So if you know anything about synthetic chemistry, you know that anything that looks like this, like sugars, are intensely painful to synthesize because there's just so many stereochemistry, so many stereocenters in them. So we'll see how these guys made it through. So essentially their synthesis is going to start with that linear tetrasaccharide fragment, and they start with, obviously throughout this whole synthesis they have to have heavily protected alcohols on all their sugars. So they start with rhamnose, and they have rhamnose protected with O-tips, which is a triisopropylsilyl group for protecting alcohols, and it's also protected with an isopropyridine, which is able to protect two of the other alcohols at once. So they can react that in a glycosylation reaction with xylose. So then they have xylose and rhamnose, and then they have to use some more funky reagents like the trichloroacetamidate. So by that point they've got to a trisaccharide, and they have good yield on this, 77% yield. And then basically they convert that again to a trichloroacetamidate as I imagine as a good leaving group to then complete the tetrasaccharide. Then basically they're going to have to remove all the they're going to deacetylate or deprotect one of the oxygen atoms, and all the other ones are covered with benzyl groups. So they can have, kind of by using orthogonal protecting groups, they can have two different ways to distinguish their many different alcohols. So basically these trichloroacetamidates, they go on the end of an alcohol, and basically what it seems like, it's got trichloro and it's basically got an imine on it. So I imagine that will be able to form a very stable compound once it's eliminated from the alcohol, and that's basically how it's going to act to be able to catalyze these reactions. So then what they do is they couple this to the linear acyl fragment, which is protected with TBS on 5 alcohols, and they react that with their tetrasaccharide. They get a pretty good yield, 89% at around room temperature. And then basically what they did after that was they, now with this acyl and tetrasaccharide, basically reacted that again to form a trichloroacetamidate, and then they had already prepared the other half of the molecule, the quillic acid, with the trisaccharide. So then they found that that served as a good glycosylation donor for the quillic acid, which allowed them to prepare QS-21 xylose. They then wanted to test whether this synthetic QS-21 had the same properties as the adjuvant from quillia bark. What they suspected was that QS-21 was the active compound, but they couldn't be sure because the real adjuvant is actually a complex mixture. What they did was they used as an antigen, they used keyhole limpet hemocyanin, which is a common carrier protein functionalized with a hapten. In this case, it's some kind of natural product containing a lot of sugars. It's called GD3-KLH. Alright, so now the fun part, they get to inject these into mice. So basically they vaccinate a bunch of C57 black 6 mice. They vaccinate them each week for 3 weeks, and then extracted some blood after the 3rd week, and basically determined if there were antibodies by the ELISA assay. And what they found was that GD3-KLH alone, so the antigen with no adjuvant, was not sufficient to cause antibody production against this antigen. However, when they used their synthetic QS-21, 10 micrograms, basically they were able to find that the mice produced, 1 million antibodies or so. The same as their positive control. So here we go. This one's their positive control. This one's no adjuvant at all. And here's their synthetic adjuvant. So you can see some mice just don't get, they're bad antibody producers, I guess, but there's a whole bunch of mice that are right up there at that high level of antibody. And again, this was measured by ELISA, so it'll allow you to determine the titer of your antibody or its potency. In summary, the authors in the GIN lab describe the chemical synthesis and structural verification of QS-21 xylose, a key isomeric constituent of the clinical adjuvant QS-21. And the establishment of preclinical adjuvant activity of synthetic QS-21 marks the necessary first step in the unambiguous establishment of the bioactivity of the 2 principal constituents of the natural product fraction. That's QS-21 xylose and QS-21 apiose. This study opens the door for the use of synthetic QS saponins of defined molecular composition in imminent clinical trials. Indeed, on the basis of these preclinical data, a protocol for the use of synthetic QS-21 for a phase 1 clinical trial with a GD3 and GD2 bivalent melanoma vaccine has been approved by an institutional review board. Thanks for watching.